Okay, today we're going to finish our talk of factoring by discussing factoring by grouping. So hopefully you have noticed that the difference in what we're looking at from our factoring is that we now have four terms rather than three terms or two terms. These four terms generally include a higher degree, so we have a cubic. What we've dealt with before have been mostly quadratic. So when we do these, we're going to group the terms first off in pairs. So we're going to draw our little arches to show what my pairs are. Then you want to factor out the GCF of each pair. So I'm looking at my numbers. The largest number that goes into 3 and 12 is 3. I look at my variables and they both have an n, and I look for the smaller exponent, so that's a 2. 3 divided by 3 is 1. If I have 3 n's and I take 2 out, I'm left with 1 n. Carry down the minus sign. 12 divided by 3 is 4. I had n squared. I took out n squared, so that's all I have left. Then I carry down, always carry down this sign as is. So we carry down the plus sign. Then I look at my last two terms. What do they have in common? 2. When I take a 2 out of 2n, I have n. 8 divided by 2 is 4. Carry down my minus sign. So hopefully you can notice that these two are exactly the same. These two factors. They're n minus 4 and n minus 4. Okay? That is the common binomial factor. So what I'm going to do is we're going to factor out that binomial factor. We're going to take it out, so we have n minus 4. And then what we have left, look at this. So with the first term, I have that left, and with the last term, I have that left. Because what we have here is a product here with an addition sign and a product here. So each of those terms, I'm factoring out the binomial factor. So I have n minus 4, then I have 3n squared plus 2. And I'm going to highlight each of those so you can follow where the terms are going. My 2 is right here, so my blue went there. My green, 3n squared, went here. So those two made up the other factor, and then my common factor is out front. All right, let's go do another one. Okay, now we have 8t cubed plus 14t squared plus 20t plus 35. So, as our first step says, we're going to group them in pairs. Then, according to our second step, we're looking for the GCF of the pairs. So, between 8 and 14, our GCF is 2. They both have a t, so I'm going to put a t there, and I'm going to take the smaller exponent. And that's going to leave me 4t, because I had 8 divided by 2 is 4. T to the third, or 3 t's, take away 2 t's, leaves me with 1 t. 4 divided by 2 is 7. I have 2 t's, take out 2 t's, and I don't have any t's left. So I have 4t plus 7. Carry down my sign. Okay? Now, what you can do, these problems are contrived. They are designed to help you practice this process. So if you're having any trouble finding that GCF, these terms have to match. So put your 4t plus 7, figure out what number goes here to get me back to 20t plus 35. What do I multiply 4 by to get to 20? Well, hopefully you see that's a 5, so 5 times 4t is 20t, and 5 times 7 is 35. And that's something to keep in mind so that if you ever get stuck when you're trying to find that GCF, because if these two terms don't match, then you're not going to be able to go any further with your grouping, with your factoring by grouping. Okay? So we take out the yellow, which is my 4t plus 7. And what I'm going to have left is my green and my blue. And we'll go highlight those. So hopefully you can begin to see that pattern. Wrong color. This is the blue one. And this is my green one. And this is my yellow one. So got a box. My students would tell me, got a box of answers. So this is the final answer on each of these problems for our first one and our next one. Now, one of the things that we really should do first every time we attempt factoring is to look for the GCF. So if you will notice in this particular expression that I actually have a number and a variable that is common to every term. So between 6, 9, 12, and 18, we have a common 3. And there's a common h in every term. The lowest exponent is a 1, so that's what my common factor is. So we divide 6 divided by 3. And I had 4 h's. I take 1 out. So each of my exponents is going to go down by 1. 4 becomes a 3. 9 divided by 3 is 3. My exponent goes from 3 to 2. 12 divided by 3 is 4. My exponent is going to go from 2 to 1. We don't write the 1. And then my last one, 18 divided by 3 is 6. And this, of course, has an exponent of 1. So if we take it down, that's an exponent of 0. Well, we don't write that. So I have this expression now. And now I'm going to do my grouping by pairs. Okay, so if I group by pairs, I'm taking out the 3h. And some people get confused with two sets of parentheses. So I'm changing this outer parentheses to a bracket so you can understand. So you kind of get to ignore it. Look at just what we have inside. What's common between these two? The numbers have nothing in common, but they both have an h. So I've got h squared because that's my lower exponent, leaving me with 2h plus 3. Remember I had 3 h's, I took 2 out, so I have 1 left. And then I had 2 h's, I took 2 out, so I don't have any left. And then to go to my next one, 4 and 6 have a common factor of 2, leaving me with 2h plus 3. Again, check it if you need to. 2 times 2h is 4h. 2 times 3 is 6. So now we have factored out our binomial. Okay, this is my common binomial factor. And this is what we have left. This is what's left of the first part. Sometimes it does that. And this is what we have left of the second part. So when I write that, and I'm going to have all factors, so I'm going to go back to the parentheses. I take out my common factor that's in yellow. And my last factor will be made up of the green and the blue. So I have h squared plus 2. Okay? And we'll go highlight again so you can see the pattern. Here is, I did that before. Here is the 2. Here is the h squared from my first term. And here is the common binomial factor. So we are finished factoring. Now, some people ask me, what happens if you don't find that GCF at first? Okay, or how do you know when to stop? So if you look at this and don't find it, or don't notice the GCF first, let me go take this and move it over to the side. Hold on. I'm going to move that over to the side, and I'm going to do this problem a different way. Okay? What if I didn't notice the GCF and I just went ahead and factored it? Between 6 and 9, I have 3. I have an h in both, and the lower exponent is 3, so I would take out my 3h cubed. And what I would have left would be 2h plus 3. So hopefully you can, again, check that. 3 times 2 is 6. 3 H's and an H gives me 4 H's. Okay? 3 times 3 is 9, H cubed. Alright, look at the last one. What do we have? 12H squared and 18H. 12 and 18 have a common 6. They both have an H. What's left is 2H plus 3. So I still, as long as you find that greatest common factor, you will still have the same situation that we've had before, and that is you have a common binomial factor. All right? So then I take out that common binomial factor. Oops, that's wrong. I want to stick with the same color. Take out that common binomial factor, which is 2H plus 3. And what do I have left is 3H cubed plus 6H. So every time you're working, you're getting down to a binomial. Now, how do you know when you're finished is you look at those two terms. We have two ways of factoring two terms, and that is what we've talked about before is a GCF, or the difference of two perfect squares. That's how we abbreviated it. So this does not have a GCF. It is not a difference, so I'm done. But this over here does have a GCF. So you got to find that GCF. So if I carry this one down, what is the GCF here? It is 3 goes into 3 and 6, and they both have an H. And take it out, and you're left with H squared plus 2. Now, is that the same thing as this? Think about it. Is 3 times 4 times 5, is 3 times 4 times 5 the same thing as 4 times 3 times 5? Okay? Are those the same thing? They are. When we multiply things, the order does not matter. So you can leave it like that if you want to. So if you don't recognize the GCF at the beginning, you can always try to find it at the end. But it's not fully factored if you have a term with common factors. Okay? So that's the end of our lesson. What I'm going to do next are a bunch of examples from our assignment, but if you're good, you can go start your assignment now. All right, here are our examples. So starting off with, okay, so I'm starting off at number 12. I'm doing the even problems from the assignment, so we can start at 10, start at 12, it doesn't matter. But do notice that the directions in the beginning are just to find the GCF of the first two terms, find the GCF of the last two terms. So all I'm asked to do is find the GCF. The largest number that goes into 10 and 25 is 5. Remember, a factor has to be smaller than either one, or it could be the same or smaller than either one of our numbers. And we look at the variable, they both have a variable, and take the smaller exponent. So that is the GCF of the first two terms. The last two terms, they're both even numbers, so 2 goes into both of them, and they do not both have a variable. So that's it. So coming back over here, my first two terms, 3 goes into 3 and 6. They both have a variable. Lower exponent is 2, so that would be 3p squared. Between 2p and 1, there is nothing other than the number 1, so we're just going to write the number 1. And you'll see in a minute how that affects your factoring. It's important to know if that's the GCF. Okay, so looking at 16, we are looking at pairing the first two, pairing the last two. So I look at those. 9 and 11 have nothing in common, but these both have a variable. So I'm going to take out my w with the smaller exponent, w squared. That leaves me with 11w. I had 3 up here. I took out 2. That leaves me with 1 left, minus 9. I have w. I have 2 up here. I took out 2. I don't have any left. And then, what's the GCF here? Well, they don't both have a variable, and we already talked about 9 and 11 not have anything in common. So we carry it down, but if you put your parentheses around it, hopefully you can see these two are the same. Okay? So that's my common binomial factor that I'm going to take out. I'm going to take out 11w minus 9, and this is what I've taken out. That's my common binomial factor. I'm left with w squared plus, and that number that we have in front of here that we don't have to write is a 1. But you're going to have something. And we look at those two. Now I went ahead and boxed it, so I've kind of told you the answer here. There's nothing left to do with this one. This is a perfect square, and this is a perfect square, but it's not a difference. So we can't do anything else with that one. Okay? Let's go to 18. I'm looking at the first two terms. 12 and 27, the largest number that goes into both of those would be a 3. They both have a k squared in them. So I'm left with 12 divided by 3 is 4. K cubed, take out k squared, leaves me with k. 27 divided by 3 is 9. K squared, take out k squared means I don't have anything left. Now this one's a little trickier. I have a minus here. Okay. Um, what do they have in common? I hope you can see they both end in 0. That means they have a common 10. So 10 out of 4k, out of 40, leaves you with 4k. 10 out of 90 leaves you with 9. Now, your inclination might be to make this a plus, but that wouldn't be the same as this. So, is it really supposed to be a minus? Because they have to be the same. Check your work. If you take a negative 10 times 4k, you get a negative 40k. If you take a negative 10 and a negative 9, you get positive 90k. So that is what it's supposed to look like. In that this is our common binomial factor. 4k minus 9, 3k squared minus 10. And 3 and 10 aren't perfect squares, so we don't even need to worry about going further than that. Okay, look at 20. I have 18h cubed and 45h squared. The largest number that goes into both of those is 9. I have an h squared in both. 18 divided by 9 is 2. 3 h's, take away 2 h's, gives me with an h, leaves me with an h. Carry down my plus sign. 45 divided by 9 is 5. And I have h squared, take out h squared, and I have no more h's left. Okay, got that minus sign again. So I always, the term in the sign in between will always be what's in front of that first term. So what goes into 8 and 20? Hopefully you can see that's 4. And that leaves me with 2h. And go ahead, 2h plus 5, but you ought to check it to make sure. Negative 4 times 2h, negative 8h. Negative 4 times positive 5 is negative 20. So, once again, this is my common binomial factor. So I have 2h plus 5, and I'm left with 9h squared minus 4. Now, look at what we have this time. 9 is a perfect square. 4 is a perfect square. And any variable with an even exponent is a perfect square. So this is what we talked about yesterday. So that is the difference of two perfect squares. So I'm carrying down my 2h plus 5. And now I take the square root of the first term and the square root of the last term. And I'm going to have that factor twice. And one time is going to be minus and one is going to be plus. And again, the order of that doesn't matter. Okay, 3 more examples. And this is of the last type that was a little more challenging because this is the one where they say completely, but they're kind of giving us a hint that we want to look for that GCF first. So I'm going to start off with what number goes into 8, 32, 28, and 12. 8 doesn't go into 28, so I'm going to go with 4. And if I take out a 4, I'm left with 2p cubed minus 8p squared plus 7p minus 28. Okay, and this is the one where we carried it down. We have to carry that 4 down, but I'm putting brackets now for this outside, and I'm going to look at the two pairs inside. And what's common with these two looks like 2p squared, leaving me with p minus 4. And this has a common 7, again, leaving me with p minus 4. Okay, and there's my common binomial factor. So carry my 4 down. My binomial factor is p minus 4, and that leaves me with 2p squared plus 7. Now I have a squared variable, but that's not a perfect square. So that's enough to tell me that I'm done. Okay, let's go to 24. 24 says 5g to the fourth minus 5g cubed plus 20g squared minus 20g. I think I've got a 5g in everything. There's a g in every term. The lowest exponent is a 1. And we know 5 goes in all those numbers. So that leaves me with g cubed minus g squared plus 4g minus 4. Okay, so I got my 5g. And I'm going to look for the common factor of my pairs. So it looks like they just have g squared in common, leaving me with g minus 1. And then these two have a common 4, again leaving me with g minus 1. So I've got my common binomial factor here. So when I write my answer, I have 5g, writing down my common binomial factor, and then what I have left is g squared plus 4. Now that's a perfect square, that's a perfect square, but that's not a difference. So I can't do anything else with it, and I'm done. Alright, I'm going to group these two to make sure that I have enough room to do number 26 in between, and then we'll be done. Let's make that a little bit smaller. And we will have finished our section on factoring by grouping. Okay, so 26. Oh, we got 36v cubed minus 126v squared plus 48v minus 168. 12 goes into that. Does 12 doesn't go into that. So let's go with 6. We're gonna go with 6, and we'll see how that works. Sometimes you gotta start over again if you don't get the largest one. So we'll take out a 6. That leaves us with 6v cubed minus 21v squared plus 8v minus 28. 6 times 6 is 36. 6 times 21 is 126. 6 times 8 is 48. And 6 times 28 is 168. So we're good. Um, so again, we put our 6, we got our bracket, because we're going to group these, and we're going to group these. Those are my two pairs. So between 6 and 21, I have a 3 and v squared, leaving me with 2v and 7. Between 8v and 28, I have 4, leaving me with 2v and 7. Well, that's nice. There's my common binomial factor. So I'm going to carry down my 6. My parentheses of my 2v minus 7, and what's left is 3v squared plus 4. Again, that's not a perfect square, so I know that I'm done. And we have factored a grouping.